Lesson 12.1, Task 1. Simplify rational expressions. You have learned to rewrite some numerical fractions by canceling out common factors from the numerators and denominators. For example, 36 over 48, both are divisible by 12. 12 goes into 36 3 times, and 12 goes into 48 4 times. So 36 over 48 can be reduced to 3 over 4. When simplifying a rational expression, a similar procedure is applied. Recall that division by 0 is undefined. So anytime we have a fraction, remember 0 can't be in the denominator because it is undefined. So that's what this means right here. Division by 0 is undefined. All right, the graph of the rational function y equals x plus 1 times x plus 4 divided by x plus 4 is shown. It says describe the graph of the function. All right, the graph of the function is a line with a hole at the coordinate point, -4, -3. All right, it says, what is the domain of the function? So the domain would be all of your x's. So it goes to the right forever, it goes to the left forever. The only point that it does not include is where the hole is. So it would be all real numbers except -4. Remember, it's always your x values when you're talking about the domain. All right, so what value of x must be excluded so that division by 0 does not occur in the rational expression? All right, x equals -4. And the reason, -4 plus 4 equals 0. So if x were -4, that would make the denominator 0, and that would be undefined. So x cannot be -4. So that would be considered an excluded value. All right, it says simplify the rational function. Since the domain of the function does not change due to the simplification, how must the simplification function be written? All right, so remember above when we reduced, anything divided by itself cancels out. So because we have an x plus 4 on top and bottom, the x plus 4 will cancel. It's like 4 divided by 4 is 1. X plus 4 divided by x plus 4 is also 1. So when I say it cancels out, it just kind of goes away. It just equals 1. And 1 times anything is just whatever's left. So what's left is the x plus 1. All right? So your equation is going to be y equals x plus 1, where x cannot be equal to -4, because we've already determined that -4 would make it undefined. All right, that's all for task 1. If you have any questions, please let me know. Lesson 12.1, task 2. All right, it says to simplify rational expressions. Consider the rational expression 4x cubed minus 12x squared minus 160x divided by 4x cubed plus 12x squared minus 40x. Factor the expression completely. Then simplify it by canceling any common factors from the numerator and denominator. All right, so let's do that first. So if you remember, factoring is just the process of rewriting something in factored form. All right, let's start with the denominator. So we have 4x cubed minus 12x squared minus 160x. I can see that they have a common factor of 4x. All right, if I factor 4x out of the first term, I'm left with x squared. If I factor 4x out of the middle term, I have -3x. And you can see that if you multiply these back together, you get the -12x squared. So all we're doing is, again, rewriting this in factored form. All right, and then 4x goes into -160x. 4 goes into 16 4 times. And so that would be -40. 4x times negative 40 is negative 160x. All right, in the denominator, I can see that they also have a 4x in common. So I'm going to factor out a 4x. So 4x times x squared, and then 4x times positive 3x, and then 4 goes into 40 negative 10 times. All right, so step 1, we factored out our greatest common factor. Now we have to see if we can factor this trinomial even further, okay? So what we need to do is see what multiplies to give us negative 40 and what adds to give us negative 3. So we're just looking at the numerator right now. So we're trying to rewrite this as 4x, and we're going to rewrite the numerator as a product of two binomials. All right, so again, just looking at the top, we need something that multiplies to give us negative 40, and we need something that adds to give us negative 3. So if you think about what multiplies to give you 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. 5 and 8 are 3 apart, so I'm going to choose 5 and 8. Now I need a negative 3, so my bigger number has to be negative, and this has to be positive. Now 5 times negative 8 equals negative 40, and 5 minus 8 gives me negative 3. So I know these are my two factors. So I'm going to have x plus 5, and I'm going to have x minus 8. All right, now if you multiply all of this back together, you're going to get what we started with. But we're going to continue on, and we're going to factor the denominator in the same manner. So we're going to try to factor this trinomial into two binomials, a product of two binomials. So we need to multiply to get negative 10, and we need to add to get 3. So we've got 1 and 10, 2 and 5. 2 and 5 are 3 apart. All right, so I need a negative, so I know I need a positive and a negative again. This time I need a positive 3, so my bigger number is positive and my smaller number is negative. So I'm going to have x minus 2 and x plus 5. All right, then it says to cancel any common factors. So 4x divided by 4x equals 1, and 5 plus x over 5 plus x equals 1. So we're left with x minus 8 over x minus 2. Now, don't forget your denominator cannot be equal to 0. So let's go ahead and look. Anything times 0 is going to result in a 0. So x cannot be 0 for 1. And then what would make this factor equal to 0? 2 minus 2 equals 0. So x cannot be 2. And then what would make this factor equal 0? Negative 5 plus 5 would be 0. So negative 5 is also a restriction. All right, so our function is this, and our restricted values are 0, 2, and negative 5. All right, let's see what the question asks. All right, it says factor the numerator. All right, so we got 4x times x plus 5 times x minus 8. So we've got this one here, and the order of the factors does not matter. Remember, multiplication is commutative and associative, so moving these in a different order would not matter. All right, so factor the denominator. We've got 4x, x minus 2, and x plus 5. And it says the common factors are 4x, because we canceled 4x's out, and our other common factor that we canceled out was x plus 5. These were common because they were in the numerator and the denominator. So the expression simplifies to x minus 8 over x minus 2. All right, now it says, what are the excluded values? Okay, and we went ahead and listed the excluded values. The excluded values are what x cannot be because the denominator cannot be equal to 0. So our excluded values are negative 5, 0, and positive 2. And those come from what x cannot equal. All right, the graph has been, or the function has been graphed here. And you can see that it's increasing here, and you can see that it's also increasing here. You can see there's a vertical asymptote at 2. That's one of our restricted values, so the function will never touch 2. And then there's a hole at 2 other places, and that would be the other 2 places on the domain where the function is restricted. All right, so it says the graph of the related rational function is shown. Write a description of the graph. All right, so the graph is 2 pieces. It is increasing on both parts. It has a vertical asymptote at 2. It has a hole at 0 and at -5. And it looks like it has that's about all I can tell about it from here. So let's see what it says here. Okay. Let's see what their answer says. Okay, it's 2 pieces, vertical asymptote at 2, graph has holes at -5 and 0, and there is a horizontal asymptote at y equals 1. Where's y equals 1? All right, if there's a horizontal asymptote at y equals 1, then they've graphed this a little bit wrong. That should not pass. Oh, well, yeah, it would, because it has a hole there. So, yes. Okay, so there is a horizontal asymptote also at y equals 1, and the graph is always increasing. All right, it says, what is the domain of the function? All right, the domain is all your x's, remember? So the domain is everything in this direction, everything in this direction. The only exception is 2, 0, and -5, and that came from our restrictions on the denominator. So all real numbers except -5, 0, and 2. How do the excluded values of the rational expression impact the graph of the related rational function? The excluded values of -5 and 0 result in holes at -5 and 13/7, and 0, what was the other one? Let's see. 0, 4. Don't know why it has 4. I don't know why it's -4. It should be 4. On the left, both of those are on the left side. So we got -5. And this should be +4, but for some reason there's a typo. That's okay. And the excluded value x equals 2 results in a vertical asymptote between the curve. All right, it says write the simplified form of the rational function whose graph was shown. All right, so we're going to have x minus 8 over x minus 2. And we have our 3 excluded values. All right, so the excluded values, again, are important because that just lets you know that the function does exist. Without excluding these points on the domain, then at certain points, these 3 points, it would be undefined. And if it's undefined, then nothing on the function would matter. So the excluded values always have to be stated with each function. All right, that's all for task 2. If you have any questions, please let me know.